Okay, so arithmetic sequences and series. Now, it's when we talk about a sequence, it's called arithmetic. It's not arithmetic. Okay, so we say the word a little bit different when we're talking about a sequence. So all an arithmetic sequences is a linear model. And instead of having a slope, we call it a common difference, and we use the letter D to represent that. All right? So instead of M for slope, we're going to use D for common difference. So that's the common difference between each term in the arithmetic sequence. So any of them that you've seen that change at a constant value, add 3, subtract 3, okay? Those are actually arithmetic sequences. And so we've already looked at quite a few of them. And like I said, all they do is produce a linear model, just like this one here does, that these are all in a line. Okay? So that will be the case for all of our arithmetic sequences. And so to make sure that something is arithmetic, we just have to do the first differences then to see whether they're the same or not. If they are, it is. If they're not, it isn't. Okay? And then on Friday then, we're going to talk about geometric sequences. And when we get to geometric sequences, those have to do with exponential functions. So the two main sequences are either arithmetic, they produce a linear model, or geometric that produces a exponential model. Okay, so first we're just going to tell whether or not these are arithmetic or not. And so we just need to, so they want us to find the common first difference and then the next term in the sequence. So we find the first difference, so we're going to do our subtraction. Remember, we always work backwards. So 14 minus 8 is 6. 8 minus 2 is 2 minus negative 4 is 6. And negative 4 minus a negative 10, right? Okay, so that'd be negative 4 plus 10, and that is also equal to 6. So here the common difference D is positive 6. So then the next term would be 14 plus 6, or 20. Okay. So all we need to do is the first difference, see if they're the same. If they are, that number is the common difference, D, and then you just need to find the next term. That's pretty easy, right? Okay. Okay. So we're going to check to see if this sequence here, which is negative 2, negative 5, negative 11, negative 20, negative 32, whether it's arithmetic or not. In most of these sequences, you're going to be able to look at them and say, okay, do they differ by the same amount each time? So from 20 to 32, is that the same as 11 to 20? No. Okay. So here we have negative 32 minus 20 minus negative 20 is negative 12. And this one's negative 9. Well, those are not the same. So this is not an arithmetic sequence. Okay. So we just look to see if they differ by the same. So now that we know what an arithmetic sequence is, right, then we're going to use a formula for finding the terms of the sequence and also finding equations for the sequence and also finding numbers given a formula. So here it says each term in the arithmetic sequence is the sum of the previous term and the common difference. So if we look at the recursive formula, remember we talked about in lesson 1, recursive formulas. And so there's a recursive formula, which just says I take my previous term and add the common difference, which is what we did to get those last terms, right? The next term, all I do is take the last term I had, add the common difference. Okay? That's using the recursive formula. Okay? The general rule for an arithmetic sequence is right here. And if you look at this, this is exactly what we used in lesson 1, that one example, to be able to find the explicit rule for the ones that were linear, that had a common rate of change. So the general rule for arithmetic sequences, a sub n equals a sub 1, our first term, plus n minus 1 times the common difference. Well, okay. So a sub 1 is the first term, d is the common difference. This is basically, then when I get that into, if I simplify that, I basically have y equals mx plus b. Okay? Since it's linear, it's really going to look just like our slope-intercept form when we're done in simplifying. So here they want us to find the 12th term of the arithmetic sequence. So to find the 12th term, that means I want to find a sub 12, which that tells me that n equals 12. So I need to know what is the first term, a sub 1, and what is the common difference. So we've got 20, 14, 8, 2, and negative 4. All right, what's a sub 1? 20. Okay, it's the first term. Okay, a sub 1 represents the first term. So in this case, that's 20. Okay. And the common difference in this case, negative 6. It's going down by 6, so it's negative 6. Okay. So then to find the 12th term, all I need to do is plug in that information. So I'm finding a sub 12, so that equals a sub 1 plus 12 minus 1 times d. Okay, you don't have to write that, I just did. All right, so a sub 12 equals 20 plus 12 minus 1 times negative 6. Now, if you want, all right, which I probably will more than half the time, where would be a better place for that value of d to be at? Okay, in front of the parentheses, okay? Because if you put minus 6 here and you don't put it in parentheses, it may look like you're supposed to subtract 6 instead of multiply it. Okay? So here we have 20. Let's see, 12 minus 1 is 11, times negative 6 is negative 66. So we get negative 46. So our 12th term in this is negative 46. Okay? So all we're going to do is we just use the rule, okay? Plug in what we know, and find the number. Okay? Okay. All right. Okay. If we're missing terms, okay? So here we want to find the missing terms in this arithmetic sequence. Okay. And we're going to use, we could do two things. We can use our general rule to find this, or maybe you could just find it without it even. Okay. But let's talk about what they are here, first of all. Now we've got, this is a sub 1, right? 17. And negative 7 would be what? A sub 5. Okay. So I know the last term, a sub n. I know the first term. Okay. Do we know what n is? Okay, n represents the number of terms, right? Okay, so n in this case would be 5. So if I put negative 7 in for a sub n, 17 in for a sub 1, 5 goes in for n, and then I could solve this equation then and find d. Right? And then once I know d, then I can do 17 plus or minus d to get the second term, and then do that to get the next term, and then do it to the next term. Okay? So we'll subtract 17 here. So we get negative 24 equals 4d. So d equals negative 6. So my missing terms would be 11, 5, negative 1, to get to negative 7. Now, let me ask you this. Okay, let's go back to lines for a second, talk about lines. What would be another name for d? Slope, right? Okay, it's rate of change. So it's slope, okay? So when we calculated slope, we said slope is equal to y2 minus y1 over x2 minus x1, right? Okay. All right, we did that with our slope. Okay. Well, let's change this to a d. All right. What things represent the y's and what things represent the x's? What would represent y and what would represent x? We have terms, right? And then we have the value of each of those terms. So I have terms 1, 2, 3, 4, 5, and then I have the values of them 17, 11, 5, negative 1, and negative 7. Okay? So which thing would be x and which would be y? X would be the term number, and y would be the term's value. So what I could do is, to find the common difference here, I could do a sub n minus a sub 1. And I want you to look at this when we do this for a second. Divided by n minus 1. Okay, let's see what we did here then. We did negative 7 was our a sub n, right? 17 was our a sub 1. We did negative 7 minus negative 17. Okay. And then n minus 1 was 4. So we took negative 24 and divided by 4, got negative 6. Okay. So you could use this to find the value of d. Okay. So you could plug it in the formula like this, or you could actually use our slope formula to find d, because all we're doing is finding the rate of change. Now, I can use a variation of that formula to find the common difference for any two terms. Okay. So instead of using term 1, if we don't know term 1, if we know another term, we can use that same common difference formula, but with different numbers. Okay. So if I call one of the terms a sub n and the other one a sub m, I can find the common difference by subtracting those values and dividing by the difference between those term numbers. Okay. And the same thing works for if we use the formula. Because if I use the original formula, then I could say that it was a sub 14, a sub 8 plus 14 minus 8 times d, okay? Which would be the same thing. Okay? So first thing we want to do is find the common difference. So we're going to do 157 minus 85 divided by 14 minus 8. Okay? The term values, the difference between them, divided by the number of terms. So this would be 77 over 72, 72 over 6, right? Which is 12. Okay. Now, there's a couple different ways I can do this next part then. Okay. So we want to think of this here, that basically what I'm doing is I'm doing a sub n equals a sub m plus m, plus n minus m times d. Okay, that's basically what I'm doing. I have two different terms, and it's just that instead of it being term 1 here, it can be any term I want it to be, as long as instead of it being a 1 here, it's whatever that term number is. Okay? So now then, to find the 5th term, I could use the 14th term, or I could use the 8th term, or, okay, I could just use my knowledge of getting from the 8th term to the 5th term, which means instead of adding 12 to get from the 5th to the 8th, I could subtract 12. Okay? So let's see what we could do. Let's look at it a couple different ways. So I could have 157 equals a sub 5 plus 14 minus 5 times 12. Okay? I could do that. Or I could use the 8th term, which would be 85 equals a sub 5 plus 8 minus 5 times 12. Okay? I could use either one of them to find the 5th term. Okay? Or I could, because I know that 85 is the 8th term, because I know 85 is the 8th term. Oh, great, what did I do that for? Right. Then I could just do 85 minus 12, and that would give me the 7th term. Subtract 12 again, and that would give me the 6th term. And subtract 12 again, and that would give me the 5th term. Okay? So our 5th term is 49, and you have 3 different ways you can get there. Use the 14th term, use the 8th term, or 1. So this is 157 equals a sub 5 plus, let's see, 14 minus 5 is 9, and 9 times 12 is 108, right? Okay. So then we subtract 108, and 157 minus 108 is 49. Okay. So you could do it either way to get to that term number. So all of those things talk about the sequences, all right? Using the formulas to find the sequence. You know, either find a specific term number or find the numbers between certain ones. Okay? Now we're going to look at what if I'm adding them all up. Okay? So what if I'm going to find the sum of that group of terms, which once again, reminder, that is called a series then. Okay? An arithmetic series is when we take all those numbers and we add them together. Okay? We looked at that yesterday as far as series are. Okay? And with an arithmetic series, you could use summation notation to find it. And you could expand and add them all up. Or there's actually a formula we can use to find the sum of an arithmetic series. And this says if we want to find the sum of n terms, which, if it's 8, then I would put 8 in for n. We take that value for n and multiply it by a sub 1 plus a sub n divided by 2. So to be able to find the sum of an arithmetic series, we need to know the first term, the last term, and how many terms there are. Now, like with any series, if you know all the numbers, you can just add them up and find the answer. Okay? And that's okay to do that. All right, write them all down, add them, find your answer. Okay? It's just if we have a lot of them, it's a whole lot easier to do it using a formula. Okay? So they do up here, they explain what the formula is, how they get the formula, okay, how they come about getting it, right? But we won't worry about that too much. It's just a matter of using it. So here they showed an example here that if I have that series that starts at 2 and goes to 10, so we would have 2 plus 10, the first term plus the last term, divided by 2, and then multiplied by how many terms there were, 5. So here we have 2 examples. They want us to find the sum. And I can put here, there are 2 methods. We could expand the series and add them together, or we can use the formula. All right? So letter A says S sub 18. That means they want us to find the sum of the first 18 terms. So to use the formula, I need to know the value of n. I need to know the first term, and I need to know the 18th term. All right, so since I'm trying to find sum of the first 18 terms, and n is 18. The first term is 13. That's nice of them to tell us what it is. Okay. Then we need to find the 18th term. Okay. Well, I can do that many ways. I could just keep doing what they're doing as far as the common difference, or I could use the formula. So a sub 18 would equal a sub 1 plus 18 minus 1 times whatever d is. So a sub 1 is 13 plus 17 times, what's it take to get from 13 to 2? Okay, subtracting 11, right? And that's the nice thing about a series when it's set up like that. All I need to know is find, okay, where's the easiest 2 numbers to find the difference of? And that's my common difference. Okay? 13 minus 2 is 11. So this is negative 11. So the 18th term is, let's see, 17 times 11, that's a negative 187, right? What's 17 times 10? 170, add a 0, right? Okay, and how many more 17s do I need? 1 more. 170 plus 17 is 187. Okay, so that's really easy. Okay, if you group things correctly, multiplying is really pretty easy. Okay? So this is negative 187 plus 13 is negative 174. Okay? So that's my last term. So to find the sum of the first 18 terms, okay, I'm going to put 18 in for n, 13 for a sub 1, negative 174 for a sub n, and divide by 2. Okay, a sub 1 plus a sub n divided by 2 multiplied by how many terms there are. So this is 9 times negative 161. Okay, which is equal to, and I'm going to do this in my head. All right. It's equal to 1610 minus 161. Okay, it's equal to 1610 minus 161. Okay, where do I get to 1610? No, 161 times 10, and then I have one less of those 161s, don't I? So 1610 minus 161 is 140, is whatever, 1549. 1449, see how close it was? And that would be negative 1449. Okay. All right, did that in my head. Isn't that great? All right, yep, calculators are very handy. Okay, now, did I have to do it that way? Nope. I could have taken my calculator and I could have started subtracting. I could have said, all right, so my first number is 13, and then plus 2, plus negative 9, plus negative 18, plus negative 29, plus negative, or negative 299, plus negative, plus a negative, what, 40, plus negative 51, plus negative 60. Anyways, you understand the point, right? Okay, I could just add them all up. Okay, find the 18 terms and add them all together. Okay, you could do that also. All right. Okay, but I'd rather use the formula because it's faster. Okay, now, letter B here. We need to find n again. A sub 1, a sub 15. Now, in this case, actually, the 15th term is much easier to find. It's just the first term's not as easy. Okay, why is the 15th term easier to find in this case? What, Melissa? Yeah, just put 15 in for k. All right, a whole lot easier than what we had to do here. Of course, obviously, if you just type that in your calculator, you can find it pretty quickly, too. All right? Okay. Yep. So n is 15. All right. So I'm going to put 1 in for k to find a sub 1. So that would be 5 plus 2 times 1, which is 7, right? And then put 15 in for k, which gives me 35. Okay, 30 plus 5 is 35. So to find s sub 15 now, because we're trying to, there's 15 terms, do 15 times 7 plus 35 divided by 2. Oh, another problem I can do in my head, okay? All right. What's 42 divided by 2? 21. Okay, so this is 15 times 21. All right, now, okay, you got to be with me here. Okay, no calculators allowed. All right, what's 15 times 20? 300. How many more 15s do I have? 1. So 300 plus 15 is 315. That was easy, wasn't it? Okay, so which one's easier? Knowing the summation notation, right? What was my number? 29 what? 2920. There we go. Okay, the center section of a concert hall has 15 seats in the first row and 2 additional seats in each subsequent row. How many seats are in the 20th row? So that means I'm trying to find a sub 20. And a sub 1 is 15. And my common difference is what? What's the common difference? 2, right? Because it's getting 2 additional seats each time. So I have 15, 17, 19, 21, and so on. So this would be 15 times 20 minus 1 times 2. Okay? All I'm using is that formula to find the nth term. Okay? So a sub 20 would be, let's see, 19 times 2 is 38 plus 15 is 53, right? Okay. All right. So to find how many seats are total, what does that mean? Okay, so we have to add them up, right? So I could do 15 plus 17 plus 19 plus 21 plus 23 plus 25 plus 27 plus 29 plus 31 plus 33 plus 35 plus 37 plus 39 plus 41 all the way up to 53, right? I could add them up in my calculator, or we can do the sum of the first 20 rows would be 20 times 15 plus 53 divided by 2. All right, which, you know what? This one is the easiest one of all of them to do in your head. Okay. By far the easiest one. Because I'm going to get 10 times 68, which is 680.